Assalamu alaikum wa rahmatullahi wa barakatuh. In the first part of this lesson, we have studied about emission of sound. Today, in part 2, we are going to learn more about reception of sound. But first, let's remember. Sound is a longitudinal mechanical wave produced by the vibration of an object in a material medium. The main parts of an electrodynamic loudspeaker are magnet, coil, and elastic membrane. A loudspeaker is an electroacoustic converter. What about the functioning of a loudspeaker? When an AC source is connected to the loudspeaker, then an electromagnetic force is created, causing the vibration of the coil. Being connected to the coil, the membrane also undergoes vibrations that lead to the emission of the sound waves. The speed of sound depends on the medium of propagation, and sound is fastest in solids since it is a mechanical wave. The objectives of this part are: explain how a microphone works and indicate the range of audible sounds heard by the human ear. Now, let's start with part 2, reception of sound. One of the most popular receivers of sound is the microphone. It is a sound receiver that converts the sound vibrations detected into electrical signals. Therefore, it is called an acousto-electric converter. Before explaining the functioning of the microphone, it's important to list its main parts, which are the elastic membrane, the coil, and the magnet. These parts are common between the loudspeaker and the microphone. Now, let's see how do these parts interfere in the functioning of the microphone. A sound wave transmitted by air particles sets the elastic membrane of the microphone in vibration. The membrane vibrates with the same frequency as the wave. Being fixed to the membrane, the coil vibrates between the poles of the magnet, and the current is induced due to a phenomena which is called the electromagnetic induction. Therefore, sound vibrations received by the membrane are then transformed into electric signals. The ear, the organ of hearing, is a sound receiver which is unmatchable by any microphone. Is there an analogy between the operation of these two receivers? The ear has three main parts. The external ear, formed of the auricle, which leads to the auditory canal. The middle ear, separated from the external ear by the eardrum, and is formed of three small movable bones called the ossicles. The internal ear, formed of the cochlea, covered with the auditory cells. How does it function? Sound waves are received by the auricle of the ear, where they produce vibrations. These vibrations are transmitted to the eardrum and then to the ossicles of the middle ear, which transmits them to the internal ear. The auditory cells of the internal ear transmit these vibrations in a nerve message as electric signals. The ear is sensitive to a limited range of frequencies called audible frequencies. The human ear can hear a sound of frequencies between 20 Hz and 20 kHz or 20,000 Hz. The non-audible sounds are called infrasounds if their frequency is less than 20 Hz, and they are called ultrasounds if their frequencies are greater than 20,000 Hz. These sounds having these frequencies are not heard by a human ear. The audible frequency range is divided into three regions. First, the frequencies ranging between 20 and 500 Hz are called deep sounds. Those between 500 and 3000 Hz are called medium sounds, and between 3000 and 20,000 Hz are called sharp sounds. One of the most popular and useful applications of ultrasounds is the echo sonar, which is a technique based on the echo of ultrasound. Some applications of the echo are: sonar is a device used in ships to determine the depth of the sea or to detect a submarine. The echography is a medical technique used to obtain images of certain organs of the body. It is done without any pain and without danger. Exploration of fossils or petrol. In geology, the echo is used in the search for oil and gas. Let's explain the principle of a sonar. A sonar is a practical application of reflection of ultrasounds. Its principle is to send a salvo of ultrasonic waves to the surface to be studied, and then to measure the time delta t between the emission of these waves and the reception of its echo. The speed of these waves is equal to the distance traveled during emission and reception divided by the time from the instant of emission to that of reception. And since the distance covered by the wave is the same distance covered by its echo, then we can say that the speed v is equal to 2d divided by delta t, which is the time interval between emission and reception, where the speed v is equal to 1500 meters per second, which is the speed of sound in the water. Let's have a direct application on the sonar. A sonar emits an ultrasound of speed 1500 meters per second down a sea and receives its echo after 400 milliseconds. Determine the depth of the water at this sonar position. Please try to solve this application first alone, then check the solution with me. The speed is given by the distance traveled by this wave and its echo divided by the time interval between the emission and the reception. Then it is equal to 2d divided by delta t. By substitution, we will get that the distance d is equal to 300 meters. Therefore, the depth of the water is equal to 300 meters. It's the end of this chapter. Thank you for watching.